All right, question number 9. We want to graph the function y equals log x. And it says we're going to use the graph icon to plot the asymptotes in 2 points. So in our course, we do have, again, the parent functions. It's in the videos. There's 2 of them, but I'm just going to go to the parent function PDF document. You can see what log looks like. It hugs the y-axis and then curves up. This is indicating a vertical asymptote. That is because all values of log have to be greater than or equal to 0. We cannot plug 0 or anything less than that into log. So it tells us to plot 2 points. Now this is not something that we can do easily by hand. You would have to use technology. However, when you go to plot a point, it tells you do not round them, do not approximate. We want to put the exact value in. So it does give us the option to put log. So if I was to write down a set of ordered pairs or numbers that I want to plug in, keeping in mind that we cannot use, sorry, I'm off the screen, y equals log of x. Okay, so we cannot use any values 0 or below. It has to be greater than 0. So basically, I can just pick a couple values. Let's say 2 and 4. What I would do is I would plug 2 and 4 in here. Log of 2 and log of 4. Okay. The calculator will compute those and give me the exact values so that I don't have to round them. Because if I were to use the calculator, and let's say I typed in log of 2, it gives me a decimal value and I can't enter all of that in. So you go to the graph, we're going to put in the ordered pair 2, and then over here we're going to put in log of 2. I'm going to add another point, and I'm going to put in 4 for the x value, and that will give me a y value. Log of 4, it will compute it. I'm just going to say done, give me 2 points. This is exponential function. This is log function. It kind of says it here. So I'm going to say log. It asks me to plot the asymptote. Now, since this doesn't have like a shift left or right, there's nothing happening. We will just put the asymptote at 0. That's the standard position. And then we're going to click to go through the 2 points. Now, those 2 points will differ if you have a shift or transformation or something like so. But once we do it, that should be all we need to graph the function. And then number 10, we want to write the interval, the domain in interval notation. Number 10, we are given f of x log base 9 x squared minus 81. All right, to find the domain of log, we take the argument. Okay, whatever we take the log of has to be greater than 0. So I will be focusing on the inside and say domain x squared minus 81 has to be greater than 0. Then we're going to set this like equality. You can do a couple different things. You can subtract 81, you can factor difference of squares. Either way, it gets you the same thing. I'll just show you both methods. So difference of squares will give us x plus 9 and x minus 9. And we can say greater than 0. Or we can just add the 81 over and we would have x squared has to be greater than 81. And then we could take square root on this side, and this will give me x has to be greater than positive or negative. Square root of 81 is 9. And then over here we will be setting them equal to 0 or greater than 0. So x plus 9 needs to be greater than 0. X minus 9 has to be greater than 0. Here I would subtract 9 and x has to be greater than -9, and x has to be greater than +9. Okay, so this method kind of, like, I know this is not going to work out right. This is the method that I'm usually more familiar with, but it seemed like this one should work. I'm not sure what I'm not thinking of correctly, but let me show you this way. When you have x greater than 9 or -9, what happens is on the positive side, if I think about a number line, I'll plug 9 and -9 on the number line. When we do the positive x greater than 9, okay, that stays the same. Well, when we change the sign from positive to negative, the sign flips, and so we're saying x has to be less than -9. So we're actually getting this section and this section. So I might be missing something on the sign flipping here, but we'll keep going. But this is what we should get. We should get from -infinity to -9, and from +9 to infinity. So here we are asked to set the argument greater than 0. That's the restriction for log. The argument is the inside part. Then it says the resulting polynomial. We are setting it equal to 0. We are looking at the factoring route. X minus 9 and x plus 9. So in the text they talk about boundary points. So this is not a method that I'm the most familiar with. This is a newer thing. So with the boundary points, they're looking at a number line and trying to see what is making this statement true. So here's 9, -9, and going to infinity. So it says the sign of x minus 9. So we can just plug in some point. Let's just say -10 over here. In the middle we'll do 0, and we'll do a +10. So if I'm looking at the x minus 9, just this part by itself, and I plug in a -10, -10 minus 9, it's going to give me a -19. -19 is less than 0, it's not greater than 0, so they're going to put like a negative sign here. So they're just plugging in a test point that's in between the sections and seeing what the sign. So on the first section we got a negative when I plugged in a number in this section. In the middle, if I plug in 0, 0 minus 9 still gives me a negative. So this middle section also is negative, okay, which matches with what they have here. And then if I do +10 minus 9, it gives me a +1. That one is greater than 0. So this one would be a positive. Then we do the same thing for x plus 9. I'm going to plug in a -10. That's going to come out negative. So I'll put a negative sign here. If I plug in 0, 0 plus 9 is a +9. So this will come out positive. And if I plug in +10, 10 plus 9 is 19. That is also positive. And then we're looking at the sign of here. So when we look at them both together, what makes this overall value greater than 0? So maybe this is what we're looking for. So when you look at each of them individual, we got the signs given here. So in the first section, if we do a negative times a negative, because that one's negative, that one's negative, this comes out positive. Okay, so that means that this section works because we want the positive section. So that's how it works with the test points. They got to do test points. Here, when we do the middle section, we have a negative times a positive. That's going to give me a negative number, and we need to be greater than 0 and so that's why the negative doesn't work. So this section we will not use. And then if we do the last section, we get a positive times a positive, and that comes out positive. So we get a negative in the middle. This section is positive greater than 0, so it also matches that this is my domain from negative infinity to 9, negative 9, and from 9 to positive infinity. I'm used to doing it with the inequalities, okay? But this way also may help you see. I'm sorry, this should be negative. Okay, so we got a check there. It says the solution set does not include or includes the boundary points. So that is talking about the negative 9 and the 9. They will not be included because the inequality sign is strictly greater than or strictly less than. So it does not include those boundary points. It says the argument x squared minus 81 is greater than 0 when x is less than negative 9, so this part, and when it's greater than positive 9. So these two sections. And lastly, we're going to put it in interval notation, so it'll be just like this. So we'll go from negative infinity to negative 9, and then we'll union, because we have two pieces, positive 9 to positive infinity.